this is Britt Caswell with another example video. In today's video, we are covering example 1 from section 4-3 in the SavvasRealize Algebra 2 textbook. The goal of this example is to write equivalent rational expressions. So we're starting out, it says, when are two rational expressions equivalent? And that's a question that people ask pretty regularly, and it's good to know what they're asking. And so my answer for it would be when there are common factors that could be added or removed to make the expressions equal to each other. Alright, so when we're dealing with rational expressions, what we're going to be doing is we're going to be factoring these and either taking factors out or keeping factors there in order to make an equivalent expression. So when you guys are dealing with these kind of weird looking fractions like this, our first step is always going to be to start by factoring it. And so when I look at this expression, I see that each of our terms has an x in it. So in my numerator as well as in my denominator, I'm going to factor an x out of each of these. So here on the top I get x squared minus 5x minus 24. And down below I get x squared plus x minus 72. And so eventually I'll be able to take those x's out, because if you're multiplying by x over x, that's the same thing as multiplying by 1. But what I want to do is I want to investigate these other ones as well. So I'm going to continue to factor. So now don't forget, those x's are still there, so don't get super excited and get rid of it yet. Alright, so that top one I can factor using the double bubble method, because a is 1 here. I'm going to fill in an x and an x. My first sign's a negative, so that comes down. And my second sign's a negative, so to get a negative 24, I have to have opposite signs. And then I ask myself, well, what multiplies to make 24? That subtracts to make 5, and I get 8 and 3. So now I'm just going to factor the expression down below. So again, I'm going to use the double bubble method just because it's a 1 in front of the x squared. My first sign is a plus, and to get a negative 72, I have to have a minus. So then what multiplies to 72 that subtracts to make 1? That's 9 and 8. So all three of these expressions here are equivalent expressions. All right, they equal each other. And so one thing we need to discuss is the restrictions on x. So notice I have not eliminated anything from the numerator or denominator yet. I've just factored it. And so my restrictions on x here are any values which would cause the denominator of our fraction to be equal to 0. Alright, now it's important that you consider these restrictions on x before you cancel anything out. Because once you start canceling things out, those zeros appear to go away. But it's still a restriction on x in the original problem. Okay? So in this case, our restrictions on x would be where x equals 0, where x plus 9 equals 0, and where x minus 8 equals 0. Alright, so on this one, the x is already equal to 0. Here, x is negative 9. And here, x is equal to 8. So these are my restrictions. So now we get to the fun part where we get to kind of start crossing stuff out. Now, understand that you can only cross things out if you have a set of stuff being multiplied out like this. So if I have an expression like x minus 7 over 2x, note that I can't cancel the x's out here. Okay, mind you, this is an example that I'm just pulling out of my head. It has nothing to do with the problem. But understand here, see how this top thing is a binomial? It's two things being subtracted. And down here, this is a monomial. So I can't just take this binomial apart when it's being subtracted here. That's not allowed. Whereas here, this is all multiplication. So these things can count as individual units that I could pull out. But if there was like a minus 4 here or something that's changing this all into a subtraction instead of multiplication, that would cause me to not be able to cancel stuff out. Alrighty, so I have an x in the top and an x in the bottom, so those are going to cancel out. I also have an x minus 8 and an x minus 8. So once we've canceled all that out, now we can create our final equivalent expression. So in my numerator, I still have x plus 3, and I can drop the parentheses because that's the only thing that's up there. And in the denominator, I have an x plus 9. And again, that's the only thing left, so I could drop the parentheses. Now, I kind of like having the parentheses there. I'm going to put that out there because I feel like it makes it easier for me to see, like when I can cancel stuff out or not. Like if I put parentheses on my x minus 7, it's a lot more clear I can't cancel an x out. But you do you. So here is my equivalent expression on this one. Now those restrictions to 0, 0, negative 9, and 8, you notice that those restrictions seem like they would have gone away. So when I'm looking for those restrictions, I can't do it based off of my final expression here. I need to make sure that I do the restrictions based off the original expression before anything's canceled out. Alright, let's do part 2 on this problem. So again, they give us this rational expression, and they want us to state our domain, so we need to state our restrictions, and we also need to factor it. Okay, so here we go. In the numerator, I see that all my numbers are divisible by 3, so I'm definitely going to factor out the GCF of 3. And then my lowest exponent is an x cubed, so I'm going to be taking out a 3x cubed. So the numerator of my fraction turns into x squared minus 6x, and then 21x cubed divided by 3x cubed is 7. Alright, so now we're going to factor the denominator of our expression. Both these numbers are even, so I'm going to divide out a 2. And my lowest exponent between these is x to the 4th. And so my expression in here, 2x to the 6th divided by 2x to the 4th is x squared. 98 divided by 2 is 49. And then x to the 4th would cancel. Alrighty, and then we have one more step of factoring, so we're not quite there yet. So the 3x squared and the 2x to the 4th, they're just going to chill there. But I'm going to break apart the parentheses that are left. So here, the x squared minus 6x minus 7, I know I have an x and an x. I drop down my first minus. And then to get a negative 7, my signs have to be opposite. And what multiplies to make 7 that subtracts to make 6? Well, that's 7 and 1. Down here, this is a difference of squares. So my difference of squares formula says that I get a plus and a minus. And then I take the square root of the first term, so the square root of x squared is x. And then I take the square root of our second term, and the square root of 49 is 7, and I just fill those in. So now here, I can do my domain, or I could state my restrictions. All right, I'm gonna state the domain here. In this one, I'm gonna show it to you guys with set notation. So here I have all values of x, where x is a real number, but x cannot equal, okay, and then I have a 0, -7, and a +7. Right, and that comes from just setting each of these expressions equal to 0. Oops. And then I close it with a curly bracket. So that is one way using set notation to state our domain or our restrictions. Alright, so now we're going to start simplifying the expression. So if I want to simplify, right, I have an x minus 7 in both the numerator and denominator. And here with the x to an exponent here, I can get rid of an x squared, but that only takes 2 out of that 4, so make sure you still have an x squared down here. And that looks like everything that reduces, right? 3 and 2 don't have any common factors. So our final equivalent expression, I have a 3, and then I have an x plus 1. And then down here I have a 2, I have an x squared, don't forget that x squared, ooh, I almost did. And then an x plus 7. And so some people are good with this as their final answer, and then other times there will be problems that'll ask you to distribute. So it just kind of depends on what your problem's asking you to do. So I'm going to distribute both of these to the parentheses just to have a final solution. So 3 times x is 3x, and 3 times 1 is 3. And down here, 2x squared times x is 2x cubed, and 2x squared times 7 is 14x squared. So here's my official final solution, although again this one works occasionally as well. Alrighty, so that is finding a equivalent rational expression. Until next time.